Hey, what's going on, my ASVAB party people? Anderson here, your ASVAB coach, and I want to thank you for watching this video. It's a free recording. That way you can raise your score, get the score you want, and the military job you deserve. All I ask is that you like, comment, and subscribe to this channel. That way we can keep putting out great content for you on a week-to-week basis. And if you like what you see in this class, feel free to check out the full website. That way you can get all of the resources that you need to pass. At the end of the day, it's about getting the score you want and the military job you deserve. So if you want to join the classes or use other great resources, those links are going to be in the video description below. Get to it, and let's ace the ASVAB. Man, we bring that energy every day, man. You know what it is. Let's go. Let's go. At the end of the day, your success is what's coming first. And I got to be real with you about it. I got to be real with you. Because if I'm not, what kind of an ASVAB coach would I be? Right? And so with that, let's go ahead and get started today, gang. We got plenty of time to work with, but let's start here. Everybody, this is a real-time question, so answer as soon as you know it. To add or subtract fractions, the fractions need to have the same, what? A, B, C, or D? What are we looking at, gang? I love it. I love it. I love it. Absolutely true. Write these notes down if you have not been in this situation before. This is well, for a lot of us, this should be a new lesson because I haven't done this lesson since like late September. So again, they need to have the same denominators. Write that down. Write that down. Now, let's be real with you guys. So, fractions, to add them or subtract them, we got to have the same denominator. Cool. I know a lot of us know that, but yes or no, do you know why they need to have the same denominator? And be honest. Give me a yes if you can articulate perfectly clear exactly why they need to have the same denominator. Give me a no if you're any less than 100% sure. Give me a yes or no in that chat box. And Jamaria and Shemaya, go ahead and type your questions in the chat box if you're raising your hand. For free sessions, I kind of keep everybody muted. That way there's no overlapping noise. And so look at that. So I want to point something out here. Everybody here typed in B and was like, yeah, denominators, same denominators. But barely anybody here that I see knows why. No, not a single yes. Not a single yes so far. And then a lot of people that didn't answer, it's a little quiet, right? And so let's be real about it. Why is it that you need to have the same denominator to add or subtract fractions? Like, let's actually learn that. That way we can actually understand this. Because remember, everybody, true or false, people generally hate what they don't know. True or false? That's true. I see that. I saw you, Rena. Yeah. No, it's all good. Hey, girl, do your thing. Do your thing. I'm the only one that can see you. You're fine. You're fine. But yeah, it's true that generally people don't like what they don't understand. And so when it comes to fractions, decimals, or anything math, everybody really looks at it like, I'm good. And they kind of just walk away. But the fact of the matter is it's understandable. It's a language. You just got to start small, and we got this. So here's the easiest way that I can really go ahead and illustrate this for you. Let's go ahead and pretend that we got 2 boxes of pizza. Okay, let's go ahead and say we got 2 boxes of pizza. Let me go ahead and take that fill out. That's not what I want. There we go. So let's say we got 2 boxes of pizza, right? The boxes are the same size, but let's go ahead here and throw these pizzas in those boxes. But here's what I'm going to do, gang. Here's what I'm going to do. 1 box, I'm going to go ahead and cut it into slices. I'm going to say 4s. I'm going to cut it in 4ths. And then this other box, I'm going to go ahead and cut it into slices, 8 slices a piece. So let's go ahead and do that. Now, look, these pizzas are the same size. The slices, they're not going to be the same size, right? And so let me ask you this. Let me go ahead and use somebody as an example. Let me go ahead and Pamela. I'm looking right at you, Pamela. I'm going to use you as an example, okay? So Pamela, let's go ahead and say that this pizza on the left, let's say that this is Pamela's pizza. And let's say this pizza on the right, let's go ahead and say that this is, I'm looking at the mic here, let's go ahead and say Angela. I'm going to say this is Angela Colina's. All right, so I'm looking at both of y'all. Let's go ahead and say Pamela and Angela, they're just hanging out, right? Just chilling out one day, chilling on the park bench. And they both got their boxes of pizza. Pamela, her pizza has 4 slices. Angela's has 8. Now let's go ahead and say that Angela goes to the bathroom and she's like, hey, Pamela, would you wash my pizza real quick? Real quick, girl, please and thank you. All right, thanks, girl. Appreciate you. And you walk away. You go to the bathroom. You go do your thing. Now, while you're gone, Pamela's like, that pizza looks pretty good. Not gonna lie, her pizza looks pretty good. And so what does Pamela do? Well, Pamela, in this story, you're a bad person. I'm not saying you're a bad person, but in this story, you are. And Pamela goes, hey, look, I'm gonna go ahead and eat one of Angela's slices. And then the criminal in Pamela was like, oh, wait, she's gonna find out. Oh, crap. Let me go ahead and grab one of my slices. And I'm going to go ahead and put that slice right there. I'm going to take that slice and put it in there. Everybody, is that going to work? Can Pamela grab one of her slices and replace Angela's slice with it? No, right? Look at all those no's there. All those no's. Now, everybody, that's the same as fractions. Notice they're the same size box of pizza. We're both talking about pizza. But what do you notice? It's the out of. It's the whole. Angela's is out of 8 slices. Pamela's is only out of 4. And so if I try to translate, if I try to add my slices with Pamela to Angela, it's not going to work because you don't have the same denominator. You don't have the same out of. This is out of 4 slices, out of 8 slices, not the same. And so that's why when Angela came back and saw Pamela eating that slice, she didn't even see her eat it. She just saw that her slice was gone. Pamela's face is all greasy. Guess what Angela did? She threw hands, rightfully so. And she got what she needed. She got Pamela's entire box, and that's the end of the story. Now, all jokes aside, though, does that make a little bit more sense when it comes to understanding why you need the same denominator to add fractions or subtract them? Cool. I'm telling y'all, math can be a little fun. It can. I'm just having a little fun with it. After the frustrating weekend I had in terms of coding and everything, this is the funnest part of my job, I'm not going to lie. So with that said, that's why you need the same denominator. It's because you need to be talking about the same whole, the same out of. That's how you can translate between those fractions. So with that, let's talk about this right here. Can we add or subtract the following fractions right away, and why? I'm going to give you 15 seconds. Go ahead and put your answer in. I'll give you 15 seconds starting now. Again, which one's the right one, though? Yes or no? Which one's the right one? You got to give the right reason as well, though. Give the right reason. Give the right reason. And 3, 2, 1, time. And that's correct. That is correct, gang. Yep. They do have the same denominator. We absolutely do. And so we're good to go. Yes, same denominators. We're good. Remember, we need to have the same out of to be able to talk about that, and we're good there. Now, let's go ahead and fast forward this thing up. Next, can we add these? Yes or no? And why? And why? 15 seconds. Go. I'm making y'all pay attention today. I know. I know. Put those answers in. There we go. 4, 3, 2, 1. Final answers here. Let's go. Still D? All right, cool. There we go. That's right. Still D. Yep. We can't add these because when you take a look here, 9, 3, not the same. Not the same. But here's the thing, everybody. Here's the thing. Let me go ahead and go back to that example with the pizza, because this is a great example to go by to really make this make sense. So when you take a look at Pamela and Angela, let me go and just put these side by side real quick. Let me erase all the hoo-ha that we had earlier. All right. So if you take a look here, again, you can't add Pamela's and Angela's slices in the same box because this is too big. And Angela's slices can't go in Pamela's. It's too small. So here's what you can do. If this is out of 4 and that's out of 8, how about we just grab that little pizza cutter and let's go ahead and cut Pamela's pizza into more slices. Watch this. So out of 4, now we have right there, and then we have right here. For some reason, they didn't want to turn into a line. Come on, do your thing. There we go. All right. And so now Pamela can steal from Angela without getting caught. Pamela, taking notes here? So yeah. So now you can take it, right? But everybody, quick question. After I made these slices, did Pamela lose or gain any pizza? Like, real question. Did she gain or lose any pizza if you just cut it into more slices? No, exactly. No, you didn't. And so that's a huge idea that we got to touch on. Huge idea. Because a lot of people seem to think that when you change the denominator of a fraction, so that way you can add and subtract them, a lot of people seem to think that, oh, the fraction's bigger now, or the fraction's smaller now. No, it's the same amount. When you're changing the denominator, all you're doing is changing the form of the fraction so you can perform the operation. That's all it is. So write that down if you haven't written that down before or don't quite understand that. Again, changing the denominator. So changing the denominator does not change the fraction's value. It does not change the fraction's value. Okay? It only expresses it or writes it in a different form so you can add and subtract it. That's all it is. It's just in a different form. It's just in a different form. That's all it is, everybody. It's just in a different form. And so Shemaya asks, so how do you change the denominator again? I got you. Yeah, you're here. I got you. That's a great question. So again, before I move on here, again, changing the denominator does not change the fraction's value. It just changes its form. It's just in a different form. That's it. So allow me, we hit 100 people in the session. What's up? But allow me to go ahead and express to y'all how this is done. So if I wanted to add these two fractions, again, I see that we got a 9 here and a 3 here, not the same, can't add them. But what we can do is write this out of 9. Everybody, let me ask you this. How many times does 3 go into 9? Three times, right? Because if I do 3 times 3, I'm going to get 9. Exactly. So watch this, everybody. Watch this. So if I go ahead, if I multiply the bottom here by 3, is that enough? Or is that wrong? Rena, you say it's wrong? Why is it wrong, Rena? You can type it. Yeah, you can type it. So Fatih says I'm wrong. John says you got to do it to the numerator. Sean says you got to do it to both. Let's see, top and bottom. Fatih says whatever you do to the top, you do to the bottom. Witsa says wrong. Okay, cool. So it looks like we're just seeing that pattern. Let's see, Rena, what we got there. Let's see. Do both the top and bottom. Okay, Jadrian, there we go. Vanessa, wrong. Okay, wrong. Rena, I'm not sure if I saw your response, but I'm assuming, I think you're mouthing you have to do it to the top too, right? Is that what you're mouthing? All right, cool. Yeah. And so, yep, whatever you do to the bottom, you do to the top. If you're going to change the denominator, you have to make sure you do the same thing to the top and the bottom. Remember, guys, we're not changing the actual value. Let me ask you this real quick. What is 3 divided by 3? 1. Exactly, right. 3 divided by 3 is 1. And everybody remember, if we're multiplying by 1, are we changing the number? No, exactly. That's why this works. That's exactly why this works. If you multiply the numerator and denominator by the same thing, you are not changing the value. You're only changing the form, the way it looks. And you can feel confident that you're doing the right thing here. And so everybody, watch this. Let's go ahead and do it real quick. What is 4 times 3, everybody? Quick. Correct, 12. And then what's 3 times 3? 9. That's right. Let me go ahead and rewrite. That's 7 over 9. 7 over 9 plus 12 over 9. Now that we have the same now that we have the same number of total slices in the box of pizza, if I got 7 out of 9 slices plus 12 out of 9 slices, how many slices out of 9 do I have now? 19. That's correct. And we're good. And we're good. And that's how we can get it done. We have to first change the denominator by making sure that they're the same. So whatever you have to multiply in the top and the bottom of one of them, or both, is what you got to do. And so I know this is an introductory example. We're going to go through some more complicated ones in a second, but we got to get there first. But the answer here was D. But now that we changed it, now we're good. Now we can add and we're all set. Next, 15 seconds. Can you add the following fractions right away? Yes or no? Go, go, go. 15 seconds. And that chat box is blowing up. I love it. I love the participation, everybody. Yep. Time. Answer is D. It is D. No, the denominators are not the same. The denominators are not the same. And so let me show you a brief example of how to do it when you're looking at this and you're like, well, 8 doesn't go into 12. What do I do? I got you. This is where LCM comes into play, or LCD, whichever way you want to say it. Least common multiple, least common denominator, both represent the same idea here. So write this down in case you have never seen this before. LCD is least common denominator. The least common denominator. And then there we go. And we grab this and just repeat it here. Let me change the color. Oops, didn't mean to do that. Let me just change the color really quick. So let's go ahead and say green, because I'm going to change that to LCM, least common multiple. All right. Those are going to be very, very important topics for you, especially if you want to deal with fractions, especially if you want to master this for the ASVAB, which everyone should be striving for. But so what you can do here, sometimes you can simplify both fractions, but I'm not going to go that route real quick. I'm just going to ask myself, hey, look, what number does 12 and 8 both go into? Ask yourself, what do 12 and 8 both go into? Dang, John, that was fast. Yeah, 24. 24. 12 goes into 24 2 times, right? 8 goes into 24 3 times. Yeah, they both go into 24. And so to be able to add these, what you can do, what you can absolutely do, I know that 12 times 2 is going to give me that 24, right? And I also know that 8 times 3 is going to give me that 24. Now remember, I'm doing the same thing to the top and the bottom. I'm doing the same thing. Now, when you do the math here, what am I going to get? I got 2 times 10. That's 20 out of 24. If I go ahead and do this right here, that's going to be 18 out of 24. And then you can add these and have yourself a good day. Then you can add them and have yourself a good day. Now, again, this is just an introduction to the idea here. I'm trying to make sure that you understand that having the same denominator is all too important. That's what's going to spell success for you. So if you need to take a screenshot of that real quick, please do. But remember that LCM, least common multiple, and LCD, least common denominator, the same idea. And that's something that you want to practice heavy if you want to get good at fractions. Seriously. So with that, let's go ahead and pop over here. What's a proper fraction, everybody? 10 seconds here. Proper fraction. Go, go, go. What is a proper fraction? Let's see. Hey, what's it? Go ahead and ask. I'll go ahead and respond to it. All right, it's time. So what do we got? A lot of us are saying B here, A here. Okay, look, it is A, or it's B, excuse me. It's B, where the numerator is less than the denominator. So it's proper when you have, let's go ahead and say 1 out of 3. Or let's go ahead and say 5 out of 6. Or let's go ahead and say 10 out of 15. These are all proper fractions because you see that the numerator is less than the denominator. It means that the part, it's less than the whole. So why would it be improper if it was more than the numerator? Like, think about it like this. If I had 10 over, let's go ahead and say 8. Think about it like this. If my pizza could hold 8 slices and I open that box and there are 10 slices there, like that's a really confusing moment, right? If your pizza is supposed to hold 8 slices and you open that thing up and there's 10 slices in there, like 2 slices stacked on top, that's improper, right? Like, great, yeah, I got extra slices of pizza, but you want to ask yourself, where did that come from, right? That is improper. This is an improper fraction. This is improper when the numerator is bigger than the denominator. That's what makes it improper, okay? Because again, if I had 10 slices of pizza in an 8 slice box, that wouldn't make a lot of sense to me. That would not. No. That's improper. Okay. And so Witsa asks, why didn't you just use the 2 for the second fraction, y3? So Witsa, great question. Let me make sure I double back to make sure that I didn't move too fast beyond anybody here. I got you. So Witsa, the reason that I used 2 here and 3 here, the goal was, remember the goal, we need the same denominator. We need the same denominator. And so all I did was, I noticed that if I turn this 12 into a 24 and the 8 into a 24, then I get the same denominator, right? And so the way that we get there is 12 times 2 and 8 times 3. And so that's why we did different numbers for each fraction. That's why. So I hope that makes sense. I hope that makes sense. And thanks for helping out in the chat box, everybody. I really appreciate that. And so with that, what I want to do here is I want to go ahead and just take you guys through some guided practice here. I want to just go straight into it because I want to make sure that we get some practice here to really warm ourselves up. This is, again, an introductory lesson to fractions, and I hope that this can be carried over into the practice that you're currently doing. So what I'm going to do here, I'm going to give you 1 minute and 15 seconds to try these problems out. There are no tricks, no word problems to go through. It's just going ahead and getting through. Now, about halfway through, I'm going to drop a hint for you in terms of what denominator they can both go into. It's still going to be your job to get it there, but I'm going to drop the hint to kind of help you out in case you're still stuck or lost. But remember, guys, at the end of the day, what's most important is trying. Because once you try, even if you're wrong, you have the ability to ask why. That way you can move forward a little more confidently. So with that said, no need to simplify the fraction. There will be, well, if you need to, you just look at the answer choices. If you see that you can simplify, then simplify, okay? I got you. That was a good question. That was a good question. So with that, let's go ahead. 3, 2, 1, 1:15. Go. Oh, and when you're done, please don't share your answer. Just type ready when you are done. Okay? Just type ready when you're ready. Don't reveal your answer. All right, so I'm going to drop the hint. Fifteen seconds left. All right, we're looking at our final 5, 4, 3, 2, 1. Answers. What do we got, gang? What do we got? Let's check it out. Let's check it out here. So let me go ahead and just take you through exactly how you might get each of these answers. So you may have gotten A if you did this. You may have gotten A if you looked at this problem and said, okay, I'm looking at this. I'm not sure what to do, but I do see that we're adding. And because I see that we're adding, it looks like I'm going to have to add 6 plus 3 to get 9, 11 plus 2 to get 13. That would have given you answer choice A. But answer choice A is incorrect. It is incorrect. So I want to make sure that we understand the mistakes that we might possibly be making. Again, if you got 9 over 13 just on a whim, like, oh, whatever, that's probably why. But remember, that's not how we take care of things. Fractions are parts of wholes. If one slice, or excuse me, if one box can hold 11 slices and this other box holds 2 slices, this is a huge slice. You can't be adding these slices when they're so different in size. You got to make sure they got the same size. And so you may have gotten B if you would have said, hey, okay, I understand that both of these numbers both go into 22. Okay, cool. So I need to write this out of 22. I'm gonna go ahead and do this right here. Let me just do it like this. I'm gonna write this fraction as out of 22, and I'm gonna write this fraction out of 22. You may have gotten B if you would have been like this. Okay, let me just drop the 6, drop the 3, let's add them, and you may have gotten 9 out of 22. Everybody, what mistake was made here? Because look, yeah, we can go ahead and multiply by 2 here, and yeah, we can go ahead and multiply by 11 here. But what was the mistake that was made? What was the mistake that was made? Exactly. All I did was change the denominator. Exactly. I didn't do it to both the top and the bottom. Exactly. Exactly. And so with that, if someone could really quick, while I continue talking, if you could just let Simone know that she needs to click the arrow on the mic to test different audio outputs, to test different test different volumes. If you could please let her know, please and thank you. She's having a little trouble hearing me. But tell her to click the arrow on the mic and then pick a different audio device. It might be like an AirPod that she has connected or something. But again, here we are. Yeah, no. We have to do it to both. And so here, we're going to make sure and multiply the top by 2. And here, multiply this top by 11. Once we do that, 2 times 6, that's going to give me, what is that, everybody? Yeah, that's right. That's 12. And Rena, be careful. You're going backwards there. It looked like 21. And so with that, now you're good. You're good. And so here in blue, 3 times 11, that's going to give us 33. So it's not going to be 9. Out of here. That's going to end up being 45. And remember, everybody, you keep the same denominator as you add because you're saying, hey, look, I got 12 out of 22, 33 out of 22, 45 pieces out of 22 that I need. That's what you're saying. Like 12 out of 22 that I need, 33 out of 22 that I need. Now I got 45 out of 22 that I needed. So notice you're not saying 44. It stays 22. It's out of. It's basically representing like the standard that you're working toward. The standard doesn't change there. Does that make sense, everybody? The denominator stays the same when you add or subtract. Yeah, well, it's absolutely. You can still add even if those fractions are improper, you can still add them just the same. And so I showed you guys how to get A, and that was incorrect. I showed you how you can get B, and that was incorrect. That's C. That's the correct way, and we're good. No, in this case, we're not simplifying. I'm just helping you go through the exercises of adding and subtracting. That's all it is. That's all it is. So what I want to do here is I really want to throw y'all into this next one here. I want to just throw y'all in and see what happens on this next one. And so I'm just looking at the comments real quick. Hey, it's all good, Mario. Mistakes happen. We're going to keep working on it, all right? Next one. Remember to just type ready when you're ready. 3, 2, 1. Let's go. Solve this expression below. And if you're already done, go ahead and try these. And we're looking at our final 5, 4, 3, 2, and 1. All right, let's see what our answers are. Let's go ahead and see what these answers are for 5 halves. Subtract 9 quarters. What do we receive here? All right, let's check it out. Let's check it out. So let's go ahead and just ignore the answers for a second. Let's just go ahead and look at these real quick. I'll go ahead and go through those other answers for those other extra problems in a moment. But let's go ahead and take a look here. Everybody, quick, yes or no? Can we subtract these right now? I see y'all on the camera. Shout out. That's right. We cannot. We cannot because we don't have the same out of. We got 2 different boxes of pizza. We got different slices. Got different slices. We need the same types of slice, right? So let's go ahead then and let's make the same number of slices. So I'm going to ask myself, what do 2 and 4 both go into? Like, what can they both multiply into? Dang, John, 4, 4, 4. I love it. Yeah, they can both go into 4. And so what I can do here is take this one over here and turn it into out of 4 because this one's already good. So I can go ahead and take the bottom, multiply it by 2, and the top. Remember, what you do to the bottom, you must do to the top, and vice versa. That way, you're multiplying by 1. And again, you're not changing the value of the number. You're just changing the way the fraction looks. That way, you can actually add and subtract it. And so 2 times 5 gives me 10. 2 times 2 gives me 4. And now I can work on this nice and easy. And now I'll receive 1 out of 4. Boom. Exactly, Dawson. Exactly. You can only do it, or if you see that you only need to do it to one side, boom, you're good. You're good. You don't need to change the denominators of everything. Yeah, you can do 8. If you did 8, you would have simplified at the end and you would have been able to still get 1/4. Yeah, you can still get 1/4. Hey, Irina, shout out. We good. All right, cool. So let's go and go to the next one here. I'm going to give y'all 35 seconds here. Go. $35 seconds. And I'm going to go back real quick and give the answers to these other problems. Let me just grab them real quick. Sorry, guys. Sorry. So the answers to these that we did just now. So those are the answers here. And now 3, 2, 1, answer for this one. Go. Okay, there we go. Exactly. This one was simple, right? Because you already have the same denominator, right? Y'all ever see a problem on a practice test or in a textbook that was so easy that you stopped and was like, this is suspect. This is kind of suspect right now. How many times have we been through that situation, right? And so this is why, yeah, this is exactly why we need to understand the rules, understand the concept itself, because you can look at something like this and be like, all right, 4/7 plus 2/7. That looks really easy. But why is it easy? Like, seriously, ask yourself, like, why is it actually easy? And so the idea is, boom, you can look at it and say, all right, look, we have the same denominator, so we can go ahead and add the numerators. Let's add those numerators. 4 plus 2 is 6. Keep that 7, so 6/7. I'll follow my rules. That's it. We're good, right? That's it. That's how you want to approach, not, I don't know why this feels easy. No, explain why it's easy. Like, if it feels easy, explain to yourself why it's easy while you do it. That way you can continue, again, building that confidence. That's what this is all about. That's what it's all about. Can we build our confidence here and get that done? And boom, you'll get B 6/7. Even if you tried to use 14, you would have gotten 8/14 plus 4/14. That would have given you 12/14. And then you can see here that you can divide them both the top and the bottom by 2 to get 6 out of 7. So you can still get to the same answer. Again, all you did was just change the way the fraction looks. You didn't actually change anything about it. And you're good. And so there we are. And so John, no, the problems you gave us earlier, denominator 14. Not here, because again, 3 doesn't go into 14. So yeah, it's all good. Again, these are good questions. Again, you asked why. And so that's how we were able to receive that result. And we're good. Next, let's go. Minute 15 again. I'm working y'all today. Let's go. Hey, Sean, it's all good. I understand. You're good. All right, we just hit a minute about 5 seconds ago. So we got 6, 5, 4, 3, 2, 1. Go. All right, let's see what we got here. Let's see. So going after it here. I'm looking at this. Everybody, yes or no, loud and proud. Can we add these fractions right now? Can we do it? No. Exactly. We need the same denominator. And so this is where you ask yourself, what do 3 and 4 both go into? Here's a nice tip, everybody. If you don't know what they both go into and you don't want to go through the work of like doing a factor tree or remembering the, the common multiples and everything, don't worry. Easy way, go ahead and multiply this by that and that by this. Like multiply 3 times 4 and you get 12. And there you are. And so you can just say that they're both out of 12 now. And how do I get there? Well, here I multiply this by 4 over 4, and that's going to give me 8. I look at the one on the right now. What I multiply 4 by to get 12? 3. Again, that's what you did. And so I'm going to multiply the top and the bottom here by 3, and I'm going to get 6 out of 12. All right, cool. And another way that you can look at it is, hey, 2 out of 4, 2 is half of 4. 6 is half of 12. Again, the value doesn't change. Only the form does. 2 is half of 4. 6 is half of 12. The same number. So now you can go ahead and add these together. Nice and easy. 8 plus 6. That gives you 14. That's out of 12. And now all you got to do here is take a look and see if you can simplify. Everybody, what are 14 and 12 both divisible by? Right. And this is called simplifying. This is what's called simplifying. Divide the top by 2, divide the bottom by 2, and that's going to give you 7 over 6. And that's why A is the answer. Yeah, what's a great point. Sometimes it is too much work to do if you go ahead and multiply them together. Like if you have something like, let's go ahead and say 7 and 14. That's unnecessary because 7 goes into 14, right? Another one that's unnecessary would be something to the effect of 15 and 20. 15 times 20 is like 300. What? 15 and 20 both go into 60. So think about that. 60 versus 300. You got to learn your factors and multiples. You got to. That's how, again, mental math. Exactly, John. I'm going to shout out Nicole right now because I already know she's going to say mental math soon. Yeah, you got to know your mental math here to get stuff done the right way. Next. Who knows how to do this? Ooh, go. Check the operation before you go. Don't assume it's addition. Judith is like, save me. I got you. Hey, Yusuf, I got you. So essentially, mental math, it's basically like being able to do the calculating in your head without actually writing it. So it's just that process, the process of doing it in your head. Yeah, I got you. And Shemaya, I know this one's different. I know this one's going to be tough, but pay attention when I show you because this is going to be a lot easier than you might think. Looking at our final 10 and 3, 2, 1, go. All right, who gave up? Who looked at this and was like, "Oh hell no." Who was like, "I ain't doing it. I ain't doing it." Be honest again. Be honest. Like I want you to be able to be honest about your frustrations. Like I'm your teacher. I'm not the drill sergeant or the staff sergeant sitting there sitting over your shoulder, seeing if you're done. Like that's not me. I'm the person that's gonna get you past that hump. And for me to help you get there, you got to be honest with me. So just hey, we're having fun too, right? And so cool. Forgot how to do it. Waiting to be taught. To be honest, I kind of forgot. Cool. When I see problems like this, I freeze up. I don't know where to start. Thanks for being honest, everybody. Thanks for being honest. So let me be real with you. First of all, you need to know the rule in terms of multiplying fractions. So let me just write this out for you. That way you can put yourself in a good position here. Multiplying fractions is 2 steps here. It's 2 steps. Number 1, go ahead, multiply straight across. So multiply the numerator with the numerator, denominator with the denominator. So just multiply through. And so basically what I'm saying is you can say you have A over B times C over D. What you're doing when I say multiply through is like this. Okay, that's step 1. And then step 2, simplify. Simplify. All right, exactly. Just multiply straight across and then simplify. And so I'm going to show you how to do it that way. Then I'm going to show you how to do it another way. So go watch this, everybody. And then we're going to call it after this problem because it is getting close to 7. But I'm going to blow y'all's minds with this. I promise you. I promise you. If someone's going to be looking at this after I'm done explaining this and you're saying like, I've seen it before, cool, that's great. But if you've never seen this before, I promise you, you're going to be like, oh my God, why didn't my teacher teach me this? I've seen it before all the time. I got you. So everybody help me out real quick. Let's go ahead and do it real quick. Let me go ahead and actually just move this over here. So again, step 1, multiply through. Step 2 will simplify. So everybody, what's 2 times 15? Help a brother out real quick. What is 2 times 15? That's right, 30. Now help me out, everybody. What's 3 times 14? What's that going to be? And that you got to know off the top of your head, right? Like if you didn't, you're sitting here like, okay, 14, 3, 12, 3, 4, right? Or you can do 3 times 10, 3 times 4, add them together, 42. But again, I'm not sitting here trying to put anybody down, just letting you know that mental math is a very good thing to learn. So 42 here. Now, everybody, what can 30 and 42 both be divided by? Simone 6, Petit 6, John 6, King Keto 6, Andre 6, Rena 6, Pamela Albert 6, Johanna 6. Exactly. Jadrian 6. Yep. Exactly. Both divisible by. So simplifying now. Both divisible by 6. And so everybody, what's 30 divided by 6? Real quick. 5. Thank you for T. And then 42 divided by 6. That's right. 7. And so my final answer here is going to be 5 out of 7. Now, again, this is the last problem I'm going to work with. So I'm going to show y'all how to take care of multiplying fractions the right way. And so, look, almost every time, probably back in school too, we've been taught, okay, go ahead and multiply it and simplify, right? here's something that you may not have known. You can simplify first before you multiply. You can simplify first to give you the easiest possible numbers to deal with. Because imagine if this was 152 over 78. Would it be that easy to find out what they both go into then? Probably not, right? It probably wouldn't be that easy. And so this is a way to guarantee yourself that you have a good shot at getting this right in the easiest and least time-consuming way possible. Watch this. So let me just go ahead and just move this above. And again, remember, guys, don't forget, the answer was 5 out of 7, right? Answer was 5 out of 7. If I were to go ahead and simplify first, so watch this, everybody. And here's why this is okay to do. Everybody, is 2 times 15 the same as 15 times 2? Are those the same? 2 times 15, 15 times 2, same stuff, right? Almost the same. I was like, same stuff, right? It's the same stuff. Yeah. And that's the thing. Like, you can interchange these things. That's all I'm saying. 2 times 15 is the same as 15 times 2. The order doesn't matter. It doesn't matter at all. And so what am I saying here? Everybody watch this. Everybody, what are 15 and 3 both divisible by? They're both divisible by 3. Let me divide the top and the bottom by 3. Watch this. That's going to turn this into 5 over 1, right? And let me use purple there. I got you just to show you. That's 5 and that's 1. Everybody, up next here, what is the same, or what do 2 and 14 have in common? It's been a long day. What did 2 and 14 have in common? They have a 2 in common. That's correct, everybody. Let's divide the top and the bottom by 2. What do we end up getting in the top here? What's going to be at the top here? That's right, a 1. 14 divided by 2 is? Now, everybody, let me ask you something real quick. Is this not the easiest dang operation that you've ever seen all day? Is this not the easiest thing? 1 times 5. Oh, what's that going to be? Oh, Lord Jesus, that is 5. I hope I don't get that wrong ever. 1 times 7. I hope I don't get that wrong ever. That is a 7 there. 5 out of 7. If I just simplify first before I multiply, that is the right way that you should be multiplying fractions, everybody, especially on the ASVAB. There's nothing worse than getting 2 big numbers, knowing you did it right, but now you got more work to do to simplify. What if you just simplified first and gave yourself the easiest possible time you could ever ask for? Boom. And there it is. And so, does that help anybody at all? Learning that rule there at all? Right on. Right on. Right on, right on, right on, guys. So if you like Cool in the Gang, go ahead and play Get Down on It back at home. Go ahead and dance to it. Do your thing. So with that said, guys, look, today was an hour-long session, but the great thing is we have 2 hours of straight-up geometry word problems tomorrow. I got a treat for y'all tomorrow, man. We're going to be doing some crazy problems that y'all may have seen shown somewhere. Who knows? But you may have seen some of these types of problems. Get ready for that tomorrow. It's 2 hours. And then we also have Wednesday, word knowledge, and then paragraph comprehension. Hey, Anderson here, your ASVAB coach. If you like what you saw in this video, make sure to give us a thumbs up, comment, and subscribe. That way we can keep putting out great content for you. Also, if you want to join my group tutoring classes or raise your score with other courses like my bootcamp courses for math and word knowledge, hey, do your thing. The links are in this video, so that way you can raise your score and get the military job you deserve. And so with that said, again, I'm Anderson, your ASVAB coach. Let me know if you have any questions. I'll see you in the next video.